like I said, my name is OBrien. I'm with University of Missouri, which is right in the middle of the states. If you can't find it, I worry about your geography. So here's my problem. This is every day on my campus times thousands, right? I have so many users, and they all have iPhones, iPads, laptops. The average number of IPs in use per person these days is something like 8 when you include all the data center services. That adds up really fast. I brought boring facts with me to kind of get it going. I've got about 18,000 wireless access points across my campus, 30,000 or so GigE ports, 78,000 users between faculty, staff, and students, and I have a pair of 10 gig Internet 2 and Internet uplinks to serve them all. All my campus buildings are fiber connected, which is nice, but it's led to some bad habits with the network. And then we have security zones defined off our firewalls that have been extended throughout virtual routers across our core. That matters because it breaks v6 for me badly. At the beginning of the year, I was multi-homed. I've got full BGP tables for I1 and I2. And I police every single user per IP so that everyone can get access, but I limit them all. And that's actually kind of challenging to do. In addition, my pair of connections, actually the pair of 10 gig uplinks, each one has Internet 1 and Internet 2 connectivity. And I treat them as an active standby scenario. Each one is a primary for one service, and then it can fail over to the other one. But we had no NAT on our campus at the beginning of this year, which was nice. It made security easy. People knew what their IP address was. Even printers get real IPs, which is terrible. I did bring some humor with me, but this is a really good estimation of where we're going. You guys are familiar with XKCD? The idea is that the Earth gets destroyed by nanobots, and they run out of IP addresses because v6 is too small. But we're kind of there today. We're approaching it with v4. We all know it. I'm running out of IPs, and so is the rest of the world. But in my world, I matter more. It's mean to say it, but it's true. So every so often I get this email, and I really hate it because it means that a user couldn't get access to my network. I got it thousands and thousands of times this year. So unfortunately, it's time to deploy NAT, which is where we were at the beginning of summer. So I got to deploy carrier-grade NAT at my campus. Before I get there, I'm kind of really taking the approach of, I need v6, but I can't really use it yet because of the sheer number of services aren't there. If I only gave you a v6 address today, you would feel like you didn't even have an internet connection. It's unfortunate, but it's true. So we're stuck. We're waiting, right? So that means I've got to deploy a whole lot of NAT in order to alleviate my problems temporarily. But what's worse is it means I'm going to have to live with this NAT on v4 until v6 is the preferred method of connectivity. So I'm kind of walk through how my network is deployed today, and then move into how it actually what I have to address to put v6 in place. We all love Visio. This is just a basic BGP configuration. I've got Internet and Internet 2 on the top. Those are my ISP routers. And then I've got a core router below them that connects to both and gets full feeds. Below that, I've got a routed switched infrastructure that talks via OSPF. This is pretty standard. I don't like OSPF as much as my coworkers do because you can't filter it very well. I like BGP. It makes me happy. I can make you tell me only what I want to hear. So that's kind of where we came from. The reality is more like this, where we have a pair of core routers at our edge. In my case, those happen to be Juniper MX960s, which are big and beefy and do a decent job. Below that, in between my DMZ switched network and my client core switch network, I've got quite a few firewalls. Luckily, I firewall zones separately. So if you're a client, you're actually behind your own dedicated firewall zone. And then if you're a data center, you've got your own data center firewall. I hope that's more prevalent than I've seen in the past. But this just, my network gets more complicated the further we go down. I'm going to avoid getting into that. We're going to focus at the top. So today I've got a pair of MXs, and each one's primary for Internet 1 and primary for Internet 2. Okay, this works well. I police these guys, all my user traffic gets policed, like I said, but I do it when they egress on my network, right? When they exit, they hit a firewall filter that samples it and will take them down to, say, 5 meg if you're on wireless, or 25 meg if you're a data center server. This matters a lot because this has to play nice with the upcoming architecture changes. So how do we make it work well? The general idea that I use is I prefer Internet 2 because it's paid for. Once I've got that connection, I don't get charged for bandwidth usage, I just get charged for my port. So in my world, Internet 2 is cheaper, which is kind of odd. So I always prefer Internet 2, and Internet 1 is my last resort. Guess where most of my traffic goes? Internet 1. So NAT is evil, but it's fun too. For CGNAT, I decided to deploy a /16 for all my campus wireless users. I hope it's enough. I'm not sure. Right now it is, but give it 6 months and I could be overrun. The nice part is it plugged into my existing structure very easily. All I had to do is assign private space, put the right DHCP entries in my management system, and I give them a private IP. But now I have to make them talk to the internet and do it nicely. So where do I deploy my NAT? At egress. But if you remember, I also do something else at egress. I police them. So I have a problem. How to NAT and police at the same time on these interfaces. And then later on, stack IPv6 onto it. So NAT problems. If I NAT on the egress interface, I ran into what I like to call the Microsoft quandary. The Windows users complained first. What would happen is, because of the way my ISP is handling routing for, say, Internet 2 peer services, if you're going to Microsoft from my campus, you go at Internet 1. But Microsoft has I2 connectivity from peer services as well. So they see the best route is back on Internet 2, because that's how I told them to get it to me. Well, if I NATed on my egress interface and I come back in the wrong place, my NAT just broke. That was a problem, and I'll tell you how to fix it. The really funny part was traceroute still worked, even though NAT was broken, which is a creepier symptom of all. But okay, so what I did was I assigned a /24 for every transit connection. One for each. One on Internet 1, 2 for Internet 1 and 2 for Internet 2. The reason I do that is so I can advertise a giant block that doesn't get filtered at the BGP tables. We've all kind of run into the idea that the internet likes to keep the table small, so a /24 is your minimum size if you want that to propagate through other people's routers. So that means I actually do burn a lot of space in this NAT pool. We use about 3 IPs. With even 30,000 users hitting it, you have 3 IPs. It gives me room to grow. I'm hoping to get some features will let me use the whole pool because it'll make security tracking easier. But that's why I had to do it. I jumped ahead too, but that's okay. So, IP6 issues with this network design. The thing you didn't see on my diagram is my IPS, because my users don't see it, so you don't need to know about it either. But it hurts me. Actually, at my border is where I do intrusion prevention. IPSs are not very good at doing V6 yet. I have yet to see, and the reason I say that is we just don't have good tools for testing that. The tool sets aren't quite there. I mean, how many of you have a real, serious, heavy-grade IPv6 penetration testing tool? Nobody. So I don't see how my security administrators can actually tell me that the IPS is doing a great job on filtering V6. I have tested IPSs that support V6, and they seem to do it. But I really don't know how many exploits are going to perform the same in IPv6 traffic. And then we get into encapsulation issues. So now you have V4 inside V6. Does the IPS know how to strip that off and look for exploits there? That's a big problem for me. That's probably my biggest concern with going forward. Border routing. I have native IPv6 connectivity on my internet to uplink today. I have a /48 for my research network, and I have a 44 for my campus. My problem is most of the tier 1 and 2 providers don't give it to their customers yet. I was excited about the talk earlier where he said they're providing v6 to their customers soon. That actually made me really happy to hear. But I have heard nothing from the likes of, say, Southwestern Bell /Quest or whoever bought them today. That's probably one of my biggest concerns. Until we get IPv6 connectivity on major I-1 transits, I don't see it becoming as prevalent as we need it to be. Now, in my building core, I'm actually hijacked at the moment. The speaker before me mentioned he has 8600s from Nortel Avaya. They're nice platforms, and they do IPv6 until you VRF. When you deploy VRFs, you can't use IPv6 inside them. Did you catch that I mentioned we VRFed all of our security zones earlier? So now I'm stuck until I get my next generation of hardware. The VRFs actually solve a lot of problems for me as far as security and routing goes, but it hijacks me for probably another year until I get a new building core. Beyond that, I've got questions as far as subnet deployment, which brings me to IPAM. IP management is going to be vital with v6. Now, the vendors out there, I know Infoblox is here, there's Blue Cat Networks is not here, but I like them, they're kind of nice guys. And then there's QIP, which is what I currently am stuck with. QIP is being a bit of a mire for me, and mostly because there's a lot of administrative overhead to upgrading their systems and servers to get the new software out. But even then, to get v6 support, I have to use the web interface for QIP. That's a deal breaker for me right now as well, because we are forced to use the graphical interface on it to get the features we need. Not all the features that we depend on are supported in the interface that does v6 support. So there's another headache. Beyond that, I think DNS names are going to get very scary. When you talk about, well, I'll deploy a /64 for a subnet, well, that's cool. My subnet can be humongous all of a sudden. So I can have a humongous number of DNS entries. That worries me more than I care to admit. I've got a lot of machines on my network, and when you start saying, how do I do DNS on v6, which I have to have, when you start looking at the sheer volume of IP addresses, that means that I have to allow all these clients to either dynamically update their host names. Well, there's Active Directory. I can just shove them off in Windows land. But it's a bigger problem than that. We really need it with Mac, Linux, Windows, whatever the next OS is. You're going to hit a point where you even need it with your phone, probably, for certain services. So IPAM is probably my biggest concern with going forward. Managing this size of the address space with v6 is going to be a pretty large headache. And beyond that, that's what I'm going to have to depend on to write sane firewall policies. Right? Now, for a client edge, it's easy. I've got a whole bunch of users. You guys need to get to the internet. That's a very simple policy. I just say, go out, connect, have a party. When I start talking about my data center, it gets scarier. What happens when a server plugs in and auto-configures an IP and then registers its name? Does that mean I have to come up with a automatically allocating firewall policy? And how do I even allow permissions for that? So there's a whole lot of interesting questions we need to answer as far as truly deploying v6 in a sane way. Statically assigning IPs will work for a while, but as we scale up, it becomes a big deal. Now, firewall policies, a little more on that. Today's policies, most of them are zone to zone if you use like NetScreen or SRX, which is what I like. But for host-specific policies, you're going to have to rewrite policies, right? I mean, you've got a new address set. And how do you guarantee that the right host keeps that address? What happens if this host that jumped on configures and then comes back up with a new IP? Does that mean I have to track things as they go along? Yeah, it gives me headaches. It really does. And like I said, it's completely dependent on whatever my IPM solution is. They have to work well together, and I don't know that the IPM people have figured out that they need to really make friends with the firewall guys for this. Let's see. Host support and enforcement, that's another headache. I don't actually have to solve it. I can make someone else do it, but I like to kind of know how they should do it, right? Security scan applications, I mentioned this. We do active security scans on everything, right? I mean, we look for holes in web applications where they can be allowed to go online. We scan even student applications at times to make sure they aren't going to create giant security holes for us. Again, it's a big deal with v6. And then you have the fact that v6 supports IPsec within the protocol. I'm going to have applications doing really interesting things inside IPsec. And in a corporate world, it's okay to turn off features like that. I actually have to trust my users. I don't like saying it. It makes me shudder. So in my world, IPv6 does feel a little like this. The tool sets really need to evolve and evolve quickly because they just don't fit, right? Part of the problem is going to be access to real v6 connectivity. The tunnel brokers help, but I don't know very many, I really don't know that very many hardcore security guys are sitting there going and saying, I've got to get v6 in my lab so I can start looking at how these exploits are going to evolve. Now, maybe there's some conversations I just haven't had yet, but it's been really quiet on that front lately. So beyond that, the older network gear really needs to go away. It needs to never ever show up again. Today, we take things offline, give them to a vendor as a trade-in or whatever, and they go end up in Africa. This stuff that doesn't support v6 needs to get recycled and demolished. We just need to get rid of it in a good way, as opposed to having it turn up in a third world country running a network there that's got to run v6. It's just going to get painful. So connectivity today, I checked this about 2.5 hours ago. My Internet 1 connection has 375,500 prefixes. Now that may sound like a weird number for those of you who have full tables. Mine's getting Internet 2 peer services injected into it by the ISP a little further up. So that's why it might seem a little off. But when I started doing BGP, the table was like 70,000 routes for the entire internet. I'm not sure how much more we really want to grow on this, but I think we're going to see more small allocations pop up, especially with the address space constraints. I don't know where it's going to top out, but what was it, about 300,000 last year, about November, I want to say? So at our current rate, we're going to keep growing, and there are going to be routers that have problems with this. Internet 2 has only got 13,000 prefixes in it, and those are v4. Not a lot, but then again, most of the players on Internet 2 have large allocations. So I don't know if it's a good indication of the percentage of connectivity on Internet 2 to say that, oh, there's this many prefixes here and there's this many here. But it's important to keep in mind that Internet 2 doesn't have quite the reach, right? Well, that's where I get my v6 connectivity from. In fact, that's where all of you get your v6 connectivity from, pretty much, because Hurricane Electric using the tunnel broker, they're sitting on Internet 2. That's where they're giving you connectivity, right? It's slowly growing, but even with, what was it, AT&T earlier? They, within network labs are pulling in connectivity from outside locations as opposed to pulling it in on their core. Until we get it prevalent, it's just not going to serve us well. Now, the University of Missouri, I do have like a 44 and a 48. And my research network has actually been IPv6 enabled for several years now, but that serves pretty low utilization research systems. However, I will give them credit though. They've been doing all their management for those systems via IPv6. And in fact, they SSH into their 8600s with IPv6, believe it or not. So I'm in a good place as far as v6 goes, because all I have to do to bring it down to my buildings is either throw a router on a stick to the side that does my v6 routing for me and trunk it through my boxes that don't support v6 yet, because they're switches, right? They'll take the packets. But it's really just a matter of getting clear of these client issues. Today, by default, my Windows administrators turn v6 off on all their new Windows 7 boxes the minute they get them, because they lose things and they break. So we come back to a test plan, right? If you don't have a test lab, please get one. Fund it. Make the money happen. you're going to have it to move forward. Oh, and installing code does not count as testing. I have a lot of coworkers who that's their version of doing a test, is they installed a new version of code, and hey, it booted and worked, and I configured something like we use, and oh, it's good. Testing means building networks in your lab and mucking with them and using them and putting client traffic behind them. Deploy v6 on a stick. You know, put a box out there, get a tunnel, put some hosts behind it, invite people to break it. Come see how it breaks. Tell me, you know, I mean, work with your guys. See, one of the number one things I've heard of this conference this week has been I had to train other people on how to deal with v6. And it takes a lot of time. v6 is complicated and a little creepy when you first look at the numbering. Once you understand it, it makes sense. And it's fairly elegant. But when we're at a stage where even, say, macOS just released Lion and they finally got their v6 support right, that says a lot about the state of v6. We're not quite there. I think we will be, but I think we're going to be stuck with v4 for about a decade before we move forward. Oh, and the last thing is to start developing a security policy today. You know, get with your security administrators and say, look, how can we actually secure systems running dual stack? If you just bring a v6 tunnel into your house, that's one thing. If you bring a v6 tunnel into my campus on a network that's supposed to be secured, you just bypassed all my security for v6 connectivity. That's wonderful. No, that's sarcasm. You guys are quiet, man. You know, we're on a university campus, but I was tempted to pull a move that a friend of mine likes to do at his security meetings. He would ask questions, or whoever asked the best question got a beer. But I thought I'd get in trouble for doing that. So you have to take a virtual beer from me, I guess. My next biggest concern is Christmas is coming. Every year, Christmas rolls around and people give their kids new stuff. Honestly, this is an estimation, but I expect about a 25% increase in wireless devices in January when the students come back from being at home. The kids that have laptops and cell phones are going to get a new tablet, or they're getting another new tablet, or they're going to get an Apple TV. I don't care. They're going to come home. They're going to come back to campus and bring more stuff that needs more IPs every year. It keeps going and going and going. So I hope that for now I've mitigated my DHCP messages, but if you saw my example earlier, that was from yesterday. Now, luckily, that's a network that's transitioning away. It's my old wireless gear that we're taking out of play, but we've left in just as a backup. So the need for v6 is there, right? We all agree that we've got to get there. I don't need to say, oh, we're out of address space. Like, dude, we're out. It's time to buy a bigger car, or whatever you want to call it. And if we don't have a good plan moving forward, I think we are going to run into trouble. The question I have today is, are we already in trouble, right? I mean, you look at the population growth, you look at the number of users on campuses. I mean, even in this room, I got all these guys on wireless. I mean, how many devices did you guys bring on average? I've got 3, right? I mean, so, I don't know. We are in an interesting place, and I'm actually glad that my core routing gear has to be replaced to deploy v6 because it gives me time to step back and evaluate where I'm going. And when they ask me, why don't we have this yet, I can say, well, I have to buy new equipment first. I need a budget. So it's good and bad in my case, right? The bad is I can't do it today, quite. I'm really, really close. I'm kind of about out of slides, but I was thinking about this, the architecture I brought up earlier, and I really did like the premise of the top-down deployment for v6. It really is the right way to do it. I was going to do it just because that's where I can support it, right? I've got v6 coming into my routers. I'm announcing my prefixes via BGP. This is not a problem. In fact, that's the easy part, and that's what kills me. We've got tier 1 ISPs that have all the gear they need. They just have to get connectivity and turn it up. They're not doing it yet. Why not? They don't make more. They don't make money for doing this. To get internet to connectivity or get v6 connectivity is going to cost them some money, and nobody likes to spend money unless they have a driver. So the real question is, will we have a killer app? The internet is the killer app? Well, I don't know. I guess the killer app is going to be when the provider says, I can't give you a connection and take your money because I'm out of address space. So there's your killer app, right? And that's kind of what we're at. I'm there. I've run out of IPs. I have a few, but unless I come up with a really clever way to mitigate my v4 shortage, man, I'll be stuck with NAT for a while, and I've got to run dual stack with it. And as soon as I can, I will be deploying dual stack. And I'm very curious to see what happens once I do that. But I have a secondary concern. When I start running dual stack, I'm going to run into services that have done it badly, right? So what happens when you have a mission critical service and you're running dual stack and it can't connect? I mean, this is the problem they have with Windows machines. They turn up these Windows machines and they try to connect via v6 to a service because they're like, oh, I can get there. But then it breaks, and the host, instead of defaulting back to v4, just breaks. We don't have a good interaction with dual stack yet. I really don't think the client platforms are quite there. So in my mind, the piece that's missing from the puzzle is the ability to run v6 native only. I don't see a path for it yet, but it's what I need to do. I need to just put out wireless networks with only v6 and say, okay, if you want to get to this v4 service, you go through a proxy, you go whatever. That's going to have to happen. That's just the only way, right? We can't keep running dual stack forever. I'm not even sure how long we really can get away with it, to be honest. As soon as, with population growth, countries, all these little countries are getting internet access now, right? Well, how long can we get away with dual stack even? So we're going to all have to push for getting critical services onto v6, and we're going to have to figure out a way to run v6 as a native protocol. It's the only way I see it going forward. That does give me headaches. It does. I mean, I think when I first looked at v6, I was like, okay, this is interesting. This is a good way to deal with it. But I hadn't started running out of addresses yet, right? I looked at it and said, okay, I've got maybe 5 years. Well, this was 2 years ago. Now I look at it and I say, I've got to put this out as fast as I can. But there's a lot of stumbling blocks, and moving forward is going to be up to, well, the power users, right? I mean, you're going to have to get your power users into it. We have to sell them on it, which means giving them a reason. I'm not sure what those reasons need to be. So hopefully that all made sense. You guys have any questions about deploying? Yeah.
I have about 6 questions.
Go for it.
Number 1, your mobility management and bring your own devices.
Yeah.
How do you handle those students maybe bringing a virus on your network and let it proliferate? Do you scan the device?
We have a couple of ways. Yeah. Oh, I'm sorry. You want to repeat the question? The question is with students bringing their own devices with mobility domains, and how do we deal with viruses or compromise issues as far as security goes? Probably the best tool I have is actually my IPS on the border, because virtually every infection likes to talk to the internet, whether it's command control or trying to infect someone else. And by triggering a response on the IPS, we can track that, create a trouble ticket, hunt them down, and if they're on wireless, I actually know who they are based on 802.1x credentials. So I have an association between their MAC address, the IP address, the 802.1x authentication. But with that information, I can find them, even if they're on private space. Private space does make it a little more difficult because of where I'm doing NAT, but we are able to actually actively quarantine users who get infected. And even at a point, we can actually block their MAC address if we can't get a hold of them, right? If they just don't answer their phone or their email, and we're like, all right, your machine's got to be off our network. And usually once we do that, they call in. So
are there any problems with that type of implementation with the v6?
I'm not giving v6 to users yet. I can't. And the reason is that the IPSs aren't quite there. And then I've got the whole firewall policy issue. I'm actually leaning towards deploying v6 on wireless fairly soon, but I'm stuck until I get a new building core to aggregate that.
And you said you were doing a policy or package steering or package shaping on the way out?
Yes.
What kind of application are you doing that? Did you have any problems with v6 using that?
That's actually, that particular application for v6 is something I'm hoping to have a really good conversation with my vendor about tomorrow. It's one of the reasons I'm here. It's a Juniper. Yeah, I've got MX960s with MSDPC blades for the NetFlow and NAT, and 4-port 10 gig R blades to actually do the shaping. And that shaping we did on even with an M20 previously, but once we exceeded about 600 megabit, it started to fall on its face just with all the load. But with that platform, I actually am able to shape actively traffic from users per IP as a firewall filter. And it works really well. It just takes a lot of room in the box to do it. And that was actually one of my stumbling blocks with deploying NAT, is because I shape at egress, and NAT is applied as a firewall filter as well. They don't really play so nice together. So my solution for that was to NAT my wireless users as a ingress on the box. So if they hit my border box and they're coming from private space, they get policed. And then I NAT them at the egress point and just ignore them as far as the policer goes at that point. And if you have a real IP, I police you at egress, period. The hit they take for that is on Internet 2, I don't normally police users. I'm like, have a party. I got the connectivity. It doesn't cost me on bandwidth. You know, download away. Kernel.org rocks for my campus, tell you what. But on wireless, they're getting policed as well. Now, the wireless policer, I think, is sort of half needed. And I say that because once you get enough users in a room and they connect to a single IP, it kind of self-polices. Even with 802.11n, there's only so much bandwidth you can squeeze out of the frequency set. So.
And have you deployed IPv6 on your phone infrastructure, like system phones?
Surprisingly, no. Today, it's all privately routed, and we're using an off-site SIP provider, essentially. So we have a dedicated set of connections. We have dedicated VRFs for the VoIP connectivity, and it's all like 172 space. So we haven't exceeded the number of phones that you'd have to really make it hurt. And even if I did, I think I'd probably just deploy another pair of boxes and have 2 netted areas. I mean, the number of phones for campus, I just don't think it's going to grow large enough yet.
And you said you have some problems monitoring all your IP space. Have you tried info blocks to monitor the V6?
No.
Everything into your, as like a third DNS?
Like I said, right now we're using QIP, which is like Lucent's, and my biggest issue there is we've been stuck kind of in the dark ages for a little while with that system. We use RHEL for all of our systems, at least for production, right? It's kind of just what my Linux guys want to do is support RHEL, period. And to do QIP on that is slightly painful. It's supported, but it seems like their documentation is never quite right for that system, and we always have to go back and forth with them to get it going. But I've looked at InfoBox just barely. I've looked at BlueCat a bit more. I kind of like their platform just for the lack of headaches, but there's a trade-off to doing an appliance-based solution as well. So it's kind of either way.
You also mentioned that you're using Tipping Point.
Yeah.
Is that to open up SSL, or is that the one that does vulnerability?
They're Tipping Point IPSs. There's an add-on to do SSL if you wanted to actually, like, say, protect a web server. Yeah. And I even did beta testing on that box, and it does work pretty well with that.
That's when it opens up the packet, the certificate.
Yeah.
Then repackages it and sends it back.
You've got 2 options with that, actually, is you can, you have to put your certificate on there. That's the first thing that sort of sucks. But it's the only way to decrypt it is to know how to decrypt it, right? And you can either decrypt it and keep it decrypted on your network and actually just pass it decrypted to your server, which is a great way to offload some of that SSL. Or you can re-encrypt and send it on. It's optional. But you can only do it for services you control because you have to have the private key.
Okay. Is that V6? Did you have any problems with that?
Oh, well.
I mean, it's slow when you put it in V4.
Yeah, no, that was my biggest concern with that box. And I mean, you just have to buy more of them essentially to split the load and then run it through a load balancer, So with V6, I didn't try it against a V6 web server, so I can't say for sure with SSL offload with V6. I did try the IPS with V6, and it reported that it was filtering, but like I said, because the tool set is so limited, it's not like I had a really easy way to load up at the time an exploit.
And as far as like, you got a lot of
Actually, believe it, I've got my MXs, and then I have a lot of Juniper firewalls. And then my building core is like Nortel, Avaya now, because they bought them out. And then it's more fun than that. Then my data center is Nexus 7000s. Yeah, we can. Any more questions with the presentation? Yep. Thanks.